The purpose of this video is to go over 6.5 problem 48. So we're looking at using the normal approximation. So first we have to calculate the mean, which is n times p. In this case we have 160 times 0.42, which gives us 67.2. And then the standard deviation is npq. So 160 times 0.42 times 0.58, because then Q is 1 minus P. So that gives me 38.976. So if I want, that's sigma squared. So sigma is going to be the square root of that. The square root of that number, which is 6.243076. So I'm going to leave it as the square root of 38.976, so I don't have to worry about carrying so many decimals out. So if I want to know the probability that x equals 65, I have to convert that to a z-score. It's going to be the probability. And I have to account for continuity. So this is from 6.5, and it turns out when we are trying to convert a discrete random variable into a continuous random variable, such as using the normal approximation for a binomial distribution, which is what we're doing in this problem, we have to add or subtract this 0.5 depending on if we're looking for the area to the right or the left, if we're looking for something less than or greater than. So here we're looking at right at 65. So we actually subtract it from the left and the right. So we're looking for the corresponding z-value for converting that. We would have 64.5 minus the mean over the standard deviation less than or equal to z less than or equal to 6.5 minus the mean over the standard deviation. So if I do these calculations, minus 67.2 and divide by, I get the probability that I get minus 0.43 less than or equal to z less than or equal to minus 0.27. So then if I look on the table, I'm looking for the area between that. So I'm looking for the area, going to the standard distribution table. If I take the larger one minus the smaller one, so the math is the area of z equals minus 0.27 minus the area that z equals minus 0.43. So minus 0.27, I go to the table, minus 0.27. So minus 0.2 and then 7. I get 0.3936. So I'd have 0.3936, and then I'm looking for minus 0.43, minus 0.43, which is 0.3336. And so if I do that calculation, 0.3936 minus 0.3336, I get 0.06. So the converting to the discrete variable to a continuous variable, we can see that here's going to be example on B, totally different calculation, but we're going to have to do it with 54 and 59, and so we want to know the probability x is less than or equal to 54, so we're really looking at 53.5 less than or equal to z, well, not necessarily z, we'll keep it x right now, less than or equal to 59.5. So we subtract 0.5 on this one, but we're going to add 0.5 on this one to take into account for that. But then also, to convert it to the z, we have n is 100, p is 0.54, so then q would be 0.46. So our mean is going to be 100 times 0.54, which gives me 54, and our sigma squared is going to be the square root of 100 times 0.54 times 0.46, which is 24.84. So if I want to take 53.5 minus 54 over the square root of 24.84, less than or equal to z, less than or equal to 54 or 59. 59.5 minus 54 over the square root of 24.84. So 53.5 minus 54 divided by the square root of 24.8 would give me a minus 0.10, less than or equal to z, less than or equal to, then if I do the same with 59, .5 minus 54 divided by the square root of 24.84, that would give me 1.10. So in this case, I'm also going to take the area at z equals 1.10 minus the area at z equals negative 0.1. So looking for 1.10 and negative 0.1. So 1.10, 1.10, I have 0.8643, so 0.8643 minus, looking at negative 0.1, negative 0.1 gives me 4602, so 0.4602. So then if I take 0.8643 minus 0.4602, I'm done with 0.4041. And the next one is going to be very similar as before, except here we're looking for the probability x is greater than or equal to 36. So we actually are going to kind of graph this. If we look at it, we had some value x, we want to know on this side. So we're going to shift the x, because we want to know if x is greater than that. So we're going to subtract the 0.5. So then we're actually going to look at 35.5. 35.5 for continuity, because we want the area on this side of it, so we subtract the left. If we want the area on the right, like on D, we're going to add 0.5. And we'll do the math here. We have n is 90 for part C, n equals 90, p is 0.44, so Q is 0.56. So I get the mean as 0.44 times 90, which gives me 39.6. And then we take 90 times 0.44 times 0.56. And we take the square root of that to get standard deviation. So 35.5. We want to know the area to the right. So we subtract 0.5 because we're taking for that in account. So we take 35.5 minus 39.6 over the square root of 22.176. And that gives me the probability that x is greater than equal to the z value, well, the z value is greater than or equal to negative 0.87. So if I look at the normal distribution curve, and I want to know, this would be 0, right? So minus 0.87. I want to know the area on this side of it. If I look at the table, the scores always gives me the area to the left. So to calculate the area to the right, I'm going to take 1 minus the area of z equals negative 0.87. So I go to the table and I find z is negative 0.87. So negative 0.8. And then I find the column that's 7. Drop that down. And I'd have 0.1922. So it's actually going to be 1 minus 0.1922. 0.1922. 1 minus 0.1922 would give me an area of 0.8078. The last one is going to be the probability that x is less than or equal to 73. So if I'm looking for the area that's less than or equal to, I shift it to the right by 0.5. So I'm really looking at 73.5. And then I'm going to have to calculate my mean and standard deviation, so I can convert that to a z-score. So I have n is 108, p is 0.72, q would then be 0.28. So my mean is going to be 108 times 0.72, which gives me 77.76, and my standard deviation is going to be the square root of 21.7728. So then I'm going to convert the 73.5 minus 77.76 over the square root of this number here, and 0.76 divided by 21.7728. This would give me a z value of negative 0.91. So I'm looking for the area to the left of that, so it's going to be straight from the table. So I'm looking for the area for the z value of minus 0.91. Minus 0.91 gives me 0.1814. So 0.1814. So hopefully this kind of explained what's going on. It looks like for A, you didn't take into account the 0.5 there, and then I'm not sure, this would have been, you know, a potential z value, but then you have to go to the table for the area. The table for the probability. And the probability would give you the area either in between 2 points, at a point, to the left of x or to the right of x. And you have to be careful with this continuous corrective factor. If you have any other questions on this, please let me know.